Welcome students. This is the second session of refrigeration. We'll see what is the next step in proceeding this refrigeration. And in the last session itself, we are trying to play this animation. You can see the animation now, and also see the right hand side of the animation, the TS diagram parallelly. So now it goes to compressor. It's light blue in color. I'm again playing that. So this becomes red in color. After getting compression, this fluid is getting red in color to show that it is having high pressure and high temperature. Then it's now moving in the condenser. Now it slowly changes to orange color, which means low temperature, high pressure. Then it goes to expansion valve. Now it is getting into blue color. We need to understand that low pressure, low temperature, liquid format is shown as blue color. Now it is entering the evaporator, where it is getting again converted to vapor, light blue color, again goes to compressor. So at the same time, parallelly, I am again playing this. You can see from 2 to 3, this red color indicator moves from top to 3. 3 is the point, I already told you, this is the point where the refrigerant becomes liquid state, as this is the liquid line of this TS diagram. Similarly, this is the vapor line. So if it starts with vapor in compressor inlet, it goes to superheated condition at point 2, and now it is getting condensed to a liquid. So this is constant pressure condensing or cooling. Now I will play. See the line, heat is getting liberated, and this is 3 to 4 is a sudden drop of pressure that has been indicated in, that is being processed in expansion valve. Then we will see 4 to 1 is the desired refrigeration effect. You can see that also heat is getting sucked in. Heat in the sense it was taking the heat. Refrigerant is taking the heat and making this surroundings cool. That is chill effect, refrigeration effect. So that is the meaning, actual meaning. That's not heating it. It is just taking the heat so that the surrounding is found to be cool. Then you can see the completion. So let's move on to the balance of the slide. It's about pressure enthalpy. Now we are going to see that enthalpy, that's an important process in this refrigeration cycle, that is called throttling, where expansion is said to occur from condenser pressure to evaporator pressure. So this throttling occurs at isenthalpic mode, that is enthalpy at the inlet 3 is the enthalpy at the outlet 4 of throttle is same. To indicate that, and also to understand the other concept called subcooling, this pH diagram is used. It is similar to TS diagram, whereas in TS diagram the doom curve is more or less evenly distributed, whereas here you can see this doom curve is slightly bent towards our screen right. So the same is applicable also here. This is called my cursor is moving on a line called saturated liquid line over the pH diagram. It goes and now it is saturated vapor line here. You can see from point 1 it is starting with saturated vapor. It goes to the compressor, pressure getting increases, the same operation. It goes to superheated condition, then condensation at constant pressure. So this horizontal line from 2 to 3, that's called condenser pressure, and from 3 to 4 it's isenthalpic pressure drop, or it's called throttling. So 4 to 1 again evaporation or refrigeration effect. So you can see another parallel diagram to this 3 to 4 operation, that is 3 dash to 4 dash. The aim is to supply a liquid refrigerant inside the evaporator, but you can see this 4 is very far away from this saturated liquid line compared to 4 dash, and you can achieve this 4 dash by giving subcooling. This subcooling is also called undercooling. So at the end of condensation, even though it is a liquid, we are again undercooling it so that no vapor, maximum of water, maximum of liquids, not water, its liquid state of any refrigerant has to move into this evaporator. So if you undercool it, it is going closer to the liquid line, so which means here it is more or less some 90 percentage liquid. I think you understand this. So that is, and again this pressure is low pressure, that's called evaporator pressure. So it goes and do the work. We'll see what is this subcooling. So before that, in order to get this performance effective, this subcooling is done. We need to know what is COP. It's called coefficient of performance, that is the measure of performance of a refrigerator. So it is given by the ratio of heat taken or refrigeration effect to the work supplied, that is compressor power. So if you speak in terms of enthalpy, it is H1 minus H4 because 4 to 1 is evaporation, and H2 minus H1 because 1 to 2 is compressor. This is from steady flow equation. This is for per kg of mass. Then subcooling, it is also called as undercooling. I already said to you, it is defined as a process of cooling the refrigerant below the condenser temperature for given pressure. So there is no change in pressure here from 3 to 3 dash. You can see 3 is top compared to 3 dash in TS diagram. This is TS diagram, whereas this is pH diagram. In TS diagram, the temperature T3 dash is low compared to T3. Then this curve 3 dash is more or less along this saturated line, aiming to make the refrigerant a liquid, more or less a liquid when it is entering the evaporator. So what is the effect of this subcooling? Refrigeration effect increases, which means the more cooled liquid, this liquid can take more amount of heat from the surfaces, more amount of heat from the place where it is maintained, where it's meant for refrigeration. Then because of this subcooling, mass flow rate per ton of refrigeration reduces. So low mass flow rate is sufficient as it is in liquid format, and it saves the cost of the refrigerant. If it is low mass, then the volume is low, then cost is low. At the same time, if volume is low, the volume of the vapor is also low, because it was converted to vapor when it is entering the compressor. So compressor handling is very low. If it is low, power of compressor, power required to drive the compressor will become very low or less compared to the other without subcooling. Then subcooling, because of our refrigeration effect REN reducing the power of the compressor, it is indirectly affecting the COP, that is, it is increasing the COP. So that's about subcooling. We will see the remaining in the next session, students. Thank you for this.